Hello everyone, I hope you're doing well. So in this video, we're going to discuss the solutions for Codeforces Educational Round 138, which was rated for Division 2. So let us quickly start with the first problem, which is cowardly rooks. So this particular problem says that we have been given a chessboard of size n cross n and m rooks are placed on that particular board, and rooks, like, they can move in one particular row and one particular column, right? So they can move anywhere in the row in which they are present, and they can move anywhere in the column in which they are present, right? So this is the property of a rook. Now it says that no two rook occupy the same cell and no two rooks attack each other. So right now they are not attacking each other. Now it asks us whether there is a way such that we can move one of the rooks into a different cell, such that, like, no two rooks still attack each other. So the initial configuration of not attacking each other should, like, remain the same. And if you carefully observe one thing, then if we have been given some chessboard like 3 cos 3 size, now it says that no two rooks initially attack each other. So if one of them is placed here, so you cannot place any other rook in this particular row and this particular, right, in this particular column and this particular row. So this is not valid. The initial configuration would always be something like this, right? They would be placed on unique rows and unique columns always, right? So now obviously when you want to move one of the rooks from its initial position, then you must have some empty place. So for example, if there is a rook present here and there is one more present here, obviously you can't move this particular thing from here to here, because obviously they will attack each other. So you must have at least one empty column like this, or one empty row like this, right? So obviously, like, if they are empty, you can move it to the other place. But again, one thing that when they are present, they will occupy initially, in the initial state, they will always occupy unique rows and columns. So we just have to check for the condition if the number of rooks is less than or equal to n or not. So m is the number of rooks. If it is less than or equal to n, the answer would be yes. Otherwise, the answer would be no. So why we are checking only this particular condition? Because I've already told that they're all initially present in this particular manner, such that all of them occupy unique rows and unique columns. But like, if it was a case when they were not occupying unique rows or unique columns, then you could have just checked whether there is an empty row or not. In this particular case, we don't even need to check, because if there is an empty row, then certainly m, the number of rooks, would less than or equal to the number of like rows and columns, right? So if this is true, then the answer would be yes. Otherwise, the answer would be no. So, like, obviously the code is very simple for this particular question. I have taken two integers n and m, and I just input some dummy values. So I'm never using these values, but I'm just taking it for the sake of input. Now I just check if m is less than n. So yeah, here it should be m is less than n, because once it is equal to n, then, like, no, in this particular case where m is equals to n, you have no place to move, right? So this should be less than n. So again, if m is less than n, then the answer would be yes. Otherwise, the answer would be no. So this was the solution for the first problem. The second problem is death's blessing. So it says that we are playing a computer game, and to pass the current level, we just have to kill some monsters. So basically, the problem is something like this. Let me just write it down. We can take this particular case. Right. So this is some array A and this is some array B. Now A of I, like this whole array denotes the health of the monsters. So the health of the monsters is 2, 6, 7 and 3, and they have some, like, special power which is denoted as B of I, 3, 6, 0 and 5. So if someone has a health of AI, like this particular monster has health of 7, then we will need 7 seconds to kill this particular monster, right? And whenever we kill a monster, it increases the health of its neighbors by B of I. For example, if I kill this particular monster, it will increase the health of its left neighbor and its right neighbor by 6, right? So now again, for the like the corner elements, there is only one neighbor, that is for the left element, it is for the right of it, and for the rightmost element, it is to the left of it. So these are the general rules that we have to follow, and obviously we will have to kill all the monsters, and we have to find the minimum time that is required to kill all the monsters. Now the first observation is that observation one is that we would at least need this much time, that is the initial health of all the monster, right? At least summation of a of I, right? I is all the elements, right? So at least this is the time we must require, because this is the minimum health of all the monsters. Now we must kill the monsters in such a way such that this particular like we don't increase the health of other monsters, or we increase it as minimum as possible. So like we need to kill it in such a way. Now obviously we would never want to take the maximum value out of these, right? So for example, if I have some values like this, and I have some maximum value in between, like let us assume that the array be something like this, right? So if I take this particular element and remove it, then the health of its neighbor will increase by x of I, right? So I will have to add x of I to my total answer once. Now I remove this element. So again, if this is x of I, if the b of I, right? If I remove this particular element, again I will have to add b of I to this particular element. Again, if this is something b of I, right? If I remove this particular element, I'll have to add b of I to the health of this particular element. Now when I'm at this particular position, you see for the first three for the first three numbers b1, b2, b3, I have just added b1, b2, b3 to my answer, right? And I have removed all of those elements from here. Now I certainly don't want to use this particular element, so what I can instead do is I can start traversing from the right. So this was bn, right? I can remove this particular element and add b of n to the health of this particular monster or this particular element. Now bn is removed. Now this is b of n minus 1, right? Again I can remove this and I can add it to this particular element. Then b of n minus 1 is added. Then this is b of n minus 2, right? Again, so this will add to the final answer. So if you observe, for removing all the elements except the element with the maximum value in the whole array b of I, what I have done is I have just added all of them, b of 1, b of 2, b of 3 plus b of n plus b of n minus 1 plus b of n minus 2. So I've added these particular values to my answer, right? So except the maximum element, if I want to form, so after I have added all these values, this will be the only element remaining. So even if I delete this will have no effect on the other values. So what I have essentially done is we have converted it into such a case such that whenever we remove an element, we always remove it from the corners, and at maximum, like the maximum health it can increase it is of only one neighbor. So we are always removing from the corner and we are always leaving the maximum element. So at the end, what I'll have to do is I'll have to add all the elements of B, array B, to my answer except the maximum element. So this way I'll have my best answer. So my final answer would be the summation of all elements of A of I and the summation of all elements of B of I except the maximum element in B, obviously, right? So now let us have a look at the code. So this particular thing says that I've taken an integer n and I've created two vectors a and b of size n. Now I take input in both of them and I initialize my answer with 0. So what I do is I just traverse through all of those values and I add it to my answer, right? Now at the end, what I'll just do is I'll subtract the maximum element of from b from my answer, right? So I'll just subtract it and then after it I can just print my answer. So this would be the solution for the second question. Now moving on to the third question for today's contest, which is number game. Now it says that Alice and Bob are playing a game. Now they say like they have an array of n positive some integers of size n. Now Alice has to choose an integer k greater than or equal to 0 and the game will continue for k stages, right? Now the stages are numbered from 1 to k, and at each of the stages Alice has to decrease k minus I plus 1, or Alice has to take an element less than or equal to k minus I plus 1 from that particular array, and if after this particular operation the array is not empty, then Bob must add k minus I plus 1 to an arbitrary element of the array. So this is the question. Now let me say that if we have some elements A1, A2, A3, A4, A5. Right. So if I have some elements like these, now if so there is some value k, now at the first in the first step, Alice will have to choose some element from this particular array such that it is less than or equal to k in the first stage. Stage 1, Alice will have to choose some element such that it is less than or equal to k. In stage 2, Alice will have to choose some element it is such that it is less than or equal to k minus 1. In stage 3, Alice will have to choose some element such that it is less than or equal to k minus 2, and so on till stage n. There will be k stages. In stage k, Alice will have to choose some element less than or equal to 1. Right. So what I want to do is I want to find the maximum value of k such that these conditions are satisfied. So as soon as Alice chooses an element, then she will remove it from the array. And after Alice chooses some element, what will Bob do? Bob will add this. For example, in the first stage, Bob will add k to any of those values that are remaining in the array. In the second stage, Bob will add k minus 1. In the third stage, Bob will add k minus 2. In the fourth stage, Bob will add 1. Right. So this is how the whole thing works. Now if you carefully observe, then the first observation 1 is Alice will always pick largest element, always pick largest. So Alice will try to pick the maximum element she can pick, always. Right. Why? Because if Alice has two particular choices, right? For example, if the current value we have to choose an element less than or equal to k, and we have exactly k here and exactly k minus 1 here. Right. Now let us like don't think about Bob, and we'll just consider the cases of in which Alice is playing the game and Bob is not present. Now if I have two values like these and I have a value k, then in the stage 1, if I choose the smaller element, then in the next stage I will have to choose an element less than or equal to k minus 1, and then I cannot choose this particular element because it is greater than k minus 1. But if I choose the greatest element present here, that is k, then in the next step, if I choose this particular element first, then in the next step I can definitely choose k minus 1 because this will be less than or equal to k minus 1 in the next stage, right? So it's the basic observation is that Alice will always choose the largest element that is possible. Observation 2 is that Bob will choose the smallest element. Bob will always pick smallest. Now the reason for this is the smallest element in the whole array is 1. Right. Now if at the current stage we have some we have a value k. Now if I add Bob adds this particular value k to 1, then the total sum would be k plus 1. Right. And this particular value will be useless. Right. So this particular value cannot be used anymore because in the next step Alice will have to choose an element less than or equal to k minus 1. But this particular value would already be k plus 1, which is greater than this particular value. Right. So Bob will always try to choose elements from the starting so as to make them useless for Alice, and she can never pick them in the further steps. Right. So this is how the whole thing works. And since the constraints are small, we can just brute force through all the values of this particular for all the values of k. Right. We can start from the maximum value of k. We can just start from testing from n, and we can go up to 0, and we can just simulate this process where Alice is always choosing the largest element and Bob is always choosing the smallest element. Right. And if we can form the answer, then we can just print it and return out of it. Otherwise at the end we'll just obviously have a default answer as 0. Right. So let me just show you the code directly. Now it says that I've taken an integer n and I take the input in it. Now I just sort the vector v given in the input. Now I can just start a loop from test is equals to n till greater than minus 1. So what I'm doing is I'm creating a variable test. So I have to test for this particular value whether this particular value of k the answer is possible or not. So I just initialize two variables, I is equals to 0 and j less n minus 1, right? So I just take my current value in test and I have to run this loop till current is present. Current is present means current is greater than 0 and I is less than equal to j, right? So what I do is while I is less than equal to j and v of j is greater than current. So obviously if Alice cannot take the current value, then obviously she will have to look for smaller elements present in the array. So while v of j is greater than the current element or the current value I want to take, I'll just decrement j. Now if while decrementing j I just go past I, if I becomes greater than j, so I just need to break. Otherwise I can use the current value and decrement current and also decrement j because I've already used it. Now if I is greater than j, again I'll have to check whether I is greater than j, then I'll increment I because Bob is going to use the smallest value and it will be useless for Alice. So after after I've completed this loop, I'll just check if the current value is 0. So what does this mean? If the current value is 0, then I have successfully completed all the case stages. So the value of current was initially equal to test. So it means that for the value of k that is equal to test, my answer exists. Then I'll just print test and return out. And at the end, when test will be equal to 0, like here, when the value of test will be equal to 0, then obviously this loop will never execute and current will obviously be 0. So 0 will print at the end, right? If none of the values from 1 to n satisfies the answer, then 0 will always be printed. So this was the solution for the third question, and I hope you guys were able to understand the solution. So till the next video drops, keep coding, stay safe, bye bye.